Hello everyone, my name is Carl. Welcome to my workshop and welcome to my YouTube channel. This video is going to be Rover gas turbine 17 and we are going to be concerned with the subject of micro switches yet again. However, not for their use for comedic effect, but for their use to perform logic functions in a piece of complex mechanism. Now, the way things are these days, I have to make a couple of statements and to make a couple of facts perfectly clear. The first one is, whatever you do, under no circumstances should you attempt to eat or otherwise ingest micro switches. They are not suitable for human consumption. The second thing that I need to mention is that the funny video that we put out yesterday, all joking apart, it needs to be said that no micro switches were harmed during the making of that video. And with that out of the way, let's get on with the film. Now, people often ask me, well, they don't often ask me, that is to overstate my part to a massive extent. I have been asked occasionally by people, how do you put these complex mechanisms and parts back together just from a series of components that are lying around in boxes or in bins or, on the floor or wherever they happen to be. Now, basically what we're talking about is taking order from chaos, and it's a pyramidal affair. So basically what we're looking at is the base of the pyramid is the most basic type of sorting or order that you can establish, and the top of that pyramid is the finished mechanism where all these individual component parts work together in unison to perform a useful function. So the first thing I do is, as you can see here, sort out all of the parts that you have into sections in a little box, and they either have to be sorted in terms of components that fit together to perform a particular function or to form an assembly, or components that are alike. And that's what I tend to do. So I have lots of these little boxes. You can get them very cheaply, and they always have a lid, which is useful to stop. Oh, hello, they found me. They're coming for me. They're coming to take me away, haha. But they have a little lid so that you don't lose any parts, which can be drastic, especially if you lose a tiny little shim like that and you don't realize you've lost it until it comes to the final assembly. So that's the first thing I do. And when I'm putting together a gearbox or other complex assembly, as I am at the moment with the rotor actuator, I've drawn a little, I usually do a trial assembly and then I draw a diagram of how it all goes together. So each of the gears in this gearbox, as you can see them here, they each have their own unique part number, and those part numbers are actually etched onto them or engraved onto them. I don't know how they managed to do it, but they did, and I had to use 6 times zoom to actually read the numbers. So what I've done is I've drawn a little diagram of how the gearbox goes together. Now I've trial assembled it, and it doesn't mean much to you, but it means an awful lot to me. And then what I've done is I've made a little sheet of paper here with sections in it with all the gears and their part numbers, so I know which one's which. So when it comes to putting it back together, it makes it a lot simpler. I've also written here in my little notebook, you can see, use 1/8 inch 3.2 millimeter, get my words out, E-clips instead of snap rings. A lot of the snap rings that I took off ended up being stretched, and I don't really want to reuse them. So fortunately I have lots of kits of E-clips and things like that. So you can see one there, look. I know that Rotax didn't use them in the original actuator, but had they had access to them when this was built, they would have used them. So we're going to use those when we reassemble it, because they're a nice solution, and they obviously they're not all stretched and gone past their elastic limit like the ones I took off are. A much better solution. So we are now looking at putting the micro switches in. So we have to find a solution to this micro switch problem. You'll remember way back when I took this actuator apart that the way that the old limit switches were mounted had allowed them to corrode along with the rest of it, and that's how they were actually mounted originally. This is from the AP, so that shows you there, look, where the cam is and where the 2 switches were. So those limit switches, they're not available, or I mean, I'm sure that there are a stock of them somewhere, but I don't have any access to that, and I've never seen any. So we're going to replace them with bog standard, in inverted commas, micro switches. So those micro switches fit onto this plate, which then sits inside of here. And we've also got a little adjuster, which is here. So one of them fits on to that thing. So you can actually, when it's in position, you can actually adjust the position of the micro switch. So we're going to have to find a way to fit micro switches in there to make this thing work. So without further ado, we shall get on with that now. So I'm just assembling the output shaft into the gearbox housing, just using a brush to put some grease on the bearing there, or the bearing bush, and then I'll put the snap ring in that holds all that in place. So that's the shaft assembled, the output shaft. And you can see on the back here, these two brass pins are where the gears fit, and you end up with two pinions driving this output gear on, so you get a nice strong drive on either side, a nice symmetrical drive to the output gear. Now before I put this gearbox back together, it should be fairly apparent that there's no point doing that until I've got a solution for this microswitch problem. That's the critical path, essentially. So what I'm going to do is put the plate in there that holds the microswitches, and I'll bolt it in just using a couple of 4BAs, so we can do a trial assembly or a trial harry around, essentially, with the microswitch position. And this is the cam, or the cam's in two halves. So we have 36 splines on that shaft. So basically we can adjust these cams around by 10 degrees at a time. And they are separate. There's two cams, so you can put them together, or you can have them kind of around, set around from each other at different angles to make different cam shapes. So we've got plenty of scope for adjustment with this. Right, so let's get these 4BA bolts in. Now these bolts pass through this housing and out of the other side, and they are actually used to locate and to mount the motor portion onto the gearbox. So there's two that go from inside the gearbox, or the microswitch casing, and there's two that pass right through and come on the outside of the motor housing. So we'll just put these in for now and clamp it in position. Try and keep it on the camera so you can see what I'm doing. There we go. That's the washer sitting flat. So once I've got this in, the idea is that I can then assemble the cams to the shaft, and we can see what kind of an arrangement we can come up with the microswitches. Although they are pretty small, they're kind of sub-miniature microswitches, they are still a little bit bigger than the old limit switches were. So we will have to look at perhaps mounting them slightly further apart or slightly further away from where they were originally mounted, or the original limit switches were mounted. Right, I've got the wrong socket here, so I'll just I'll put this together and I'll bring. Hello everyone, my name is Carl. Welcome to my workshop and welcome to my YouTube channel. Do you like the new t-shirt? Look at that, Rover gas turbines. Merchandise on the channel. So I'm back from work and we're back in the workshop. We're back on the Rotax actuator. And our job today, or our task in this video, is to get these micro switches mounted in the switch housing and then carry on with rebuilding the gearbox and get the actuator back together again. Whilst I've been away at work, we've had a component arrive for the engine, a very important part of the engine system. So we'll be having a video about this. I'm going to keep it under wraps for the time being, but it is a very interesting and very important part that we need for the engine. So without further ado, let's get on with the video. So hopefully you should be able to see more or less how this is going to go. So the two micro switches will be kind of in the opposite orientation to each other, and then the cam comes around and operates them. I've managed to get this one, I've got it in position where it's actuated, and I've managed to get a mark at 90 degrees either side of the micro switch. So we can take that off, take the adjusting plate off and drill some holes in it. What I've done is I've put the switch mounting plate in and I've just temporarily secured it with a couple of 4BA screws, and so we can actually line these switches up. So they obviously they're slightly larger than the original limit switches that were in there, but they're going to do the job for us. And I suspect that somewhere in the world there are languishing on a shelf a box full of the limit switches for these Rotax actuators, but I don't have any access to them, and I expect they're also very closely guarded because they'll be needed to keep heritage aircraft flying. So the micro switch is the way forward. So we'll get this plate off here, this one here, look, I can't even point to it, this one here, and we'll try and drill some holes. There'll be 8BA, and we'll try and see if we can get this to work. So here's where we're at now. I've managed by nefarious means to get the micro switch clamped in a position where the cam's actuating it at the right point, and I've clamped it with the small toolmaker's clamp there to the adjustable plate, and the other larger toolmaker's clamp is clamping it to this piece of wood, and I'm going to try to match drill it in situ, hopefully without moving it. So I apologise if you can hear the sound of a circular saw outside. My neighbour's having some work done by some joiners. But I'm going to use my 90-degree DeSutter collet drill to do this, because it's lightweight and I can get it right over where I want it. And I can also just put light thumb pressure on the top. You can't see it, can you? Put light thumb pressure on the top like that, and it will just guide it in. So let's try and get it so you can see it, and let's give it a go. Okay, here we go. Let's try the next one. Right, that's just got two holes through that wood, through the wood. It is through the wood, but through the mounting plate. So we'll get some screws in that now. We'll get it back onto, or into rather, the switch housing, and we will see where we're at. So a few minutes for you, or even a few seconds for you, in terms of time on the video, has been a few days for me. And what I've decided to do is I've decided to go with the micro switches with the levers fitted to them. I did take the levers off because the idea was that the cam would just operate the button, and you can see there, look, where I chopped the lever off. The cam would just operate the button. But I found it more satisfactory operation-wise if the cam operates the lever. So as I rotate it round, you can see there it's making the lever, and you can also see that the scribed line is at 90 degrees to the datum point, which is down there, basically facing where the breeze connector was, is the datum point. So when I spin that around, it's a little bit wibbly wobbling just now because it hasn't got the end cap with the other bush in for the bearing, but there's that making. So I'll show you how that's fixed to the plate in a second. So the mounting holes in these micro switches are M2.5, and I've got a kit of M2.5, M2 and M3 bolts. So M2.5 it is, and they're countersunk on that side, look. And then another good reason for having the lever is that it's steel, so it gives more of a hard wearing surface against the cam as it's rotating and making contact with the switch. So what I've done is I've put the spacer and the spline bush on, the bush that runs in the bronze bearing in the end cap. I've bolted in the switch with just the one 4BA bolt. The other 6BA goes in that slot there. So you can see that it's roughly midway in the adjustment travel. So what we'll do is we'll put this cap on, and that should take out all the slop from the shaft. I'll get you in a position where you can hear the switch making, and I'll rotate it. I'll let you know when it's done 90, and we should be able to hear that switch making. Right, so at the moment, the scribed line on the shaft is facing towards the breeze connector position, which is the datum. And I'll rotate it through 90 by turning the gear underneath, and we should hear the switch make. So listen in. Did you hear that? That's it gone through exactly 90. It's pointing at the other datum point scribed on the housing. So back to the 0 datum, and then we'll move it around to the 90 datum again. You should hear it. Hopefully the mic picked that up. So that's the switch plate work basically finished now, and you can see how I've mounted the micro switches. So this one here has had to be positioned slightly round from this one, not directly opposite, just purely because of the fouling of the contacts on the micro switch housing side of the case there. And I've had to snip off this contact on the other micro switch in order for it to clear the mounting screw. Well, that was the normally open connector. We don't need that anyway. We only need the common and the normally closed, so that's okay. So I'll zoom in a little bit for you so you can see it. Hopefully that'll focus properly. So you should be able to see, if I turn the gear, when the scribed line on the shaft gets up almost to the top, the micro switch makes, and then we'll bring it round as if the motor's turning it, and about 90 round from that position the other micro switch makes. So I've got them perhaps half a degree off, just because I don't want the actuator to be slamming hard into the stops of the valve that it operates, the HP fuel valve. But that will definitely open the valve for us. So I'll take this micro switch plate off in a minute, and I'll show you how the switches are mounted. This bolt here is where the ground connects to, so it's on an insulated bush. So the ground comes in onto there, and then it goes up to the motor from where the cables come in from the connector here. So we'll get the switch plate off now, and I'll show you how they're mounted. One thing that I should point out is you can see that you've got these slots here, and this is held in place, or the micro switch plate is held in place by the bolts that run through, and they actually attach the gearbox or the motor portion to the gearbox itself. And one of the cams has just fallen off, I think, but never mind, we'll get it in a second. So this whole plate can be rotated within the confines of these slots, so that actually allows you to adjust the operating position of the switches very slightly. And this one's a little bit more adjustable because it's on this plate, so I can move that one as well. So within the sort of the realms of moving through the range of movement of these slots and also this plate, I've managed to get the switches where I want them. So here's the plate that I've just removed from the housing, and you can see underneath, look, that's how they're fitted, just countersunk M2.5 screws. And it's the same for this the plate here. You can't see them obviously because they're underneath the plate, but I think I've shown you that before already in the video. And then there's the insulated it's not M, it's 6BA, the insulated 6BA that's used for the ground. So what we're going to do now is start on assembling the gearbox. Right, so Rotaxuator gearbox rebuild. So here is where the gearbox is assembled onto the back of the switch housing. The back of the switch housing forms the forward face of the gearbox housing. So I have got my notebook here, into which I've already done a trial assembly, and the trial assembly I recorded with a little diagram, as you can see here, and I'll try and show you that. Can you see that? It's perhaps not the best diagram in the world, but it means a lot to me. And I've labelled all the component parts, all the spacers and gears and shims and everything else that goes together to make up the gearbox. Now, I spoke about earlier on in the video about how I like to sort everything into similar component parts and sizes in a little box like this when I reassemble any kind of mechanism. I've done the same thing with the gears, and what I've done is I've made a little sheet up like this, look, and I've labelled up the gears in each part of the sheet according to their part numbers that are actually inscribed on them, or engraved on them I should say, and I had to use about 10 times magnification to actually be able to read the part numbers on the gears. And I've written them on, and I've put each gear where it needs to be so that LX222 is next to LX222 and so on and so forth, so I know what gears what on there. And then I've written here, look, the numbers of where they all go, so it should be relatively he says, straightforward to assemble it. Now, going to be lubricating it. They were lubricated with grease, and according to the book of words, it's XG293, which is basically multi-purpose lithium-based grease. So I'm just going to be using this stuff here. It's relatively inexpensive, but it'll do the job. So I've decanted some of that into a little pot, and I've got my brush. What I intend to do, I think, is I'll grease up these shafts that are the two main shafts of the gearbox that hold all the gears, and then once I've assembled everything, I'll grease it after I've assembled it, just in case it needs to come apart, which it undoubtedly will do at some point during the assembly procedure, and I don't get absolutely covered in grease, because we all know how much I detest the stuff. It does have its applications, it does have its role, but I'm not massively fond of it, having spent several years doing that milling machine, as you're all aware. So without further ado, we'll get on with starting to put... So I've got you in the rostrum position, as I like to call it, and hopefully you're going to be able to see what I'm doing from up there. So I'm just going to put some grease onto here, onto these shafts. Oh, actually, before I start assembling this, I actually need to measure these shafts. And if you can hear a circular saw, that's because my neighbour's having some building work done. So apologies for that. Right, so I'll just measure what these shafts are, because I do need to know that for later on in the process. Let's have a look. Eighth inch. Right, okay, that's good. Almost 1/8 inch, 0.123. Right, so what I need to do now is put a thin shim on each one of these. And when I say a thin shim, I'm talking 4 thou. That's what these are, they're 4 thou. And they strike me as being hardened, and they're essentially intended to act... Oh, don't lose it, Carl. They're intended to act as thrust washers, really, I guess. Right. And they've got a little bit of grease on them from running along the shaft that I've just put the grease on. So we have 2 gears that go onto these 2 shafts, and the 2 pinions on those gears drive the output gear from either side, so we get a nice balanced drive. Let's put some grease on that gear. And they are part number RX888. So going to my handily positioned bit of paper here with all the gears on, let's get the RX888, of which there should be 2 of, and there is. So 1 RX888, I'm not going to do the count from Sesame Street, don't worry. I couldn't resist it, sorry. 1 RX888, 2 RX888, right, there we go. Right, I'm going to stop doing that, you'll be pleased to know. Right, so what goes on now is another 2 thin shims, and then the next set of gears. So I'll continue in this vein, and I'll bring you back when we're a bit closer to it being assembled, because I'm sure you don't want to watch me do this. Maybe you do, I don't know, but yeah, I'm going to spare you. So I've brought you back when I'm kind of halfway through. It's going well. So this is AZ144 gear, which is now going on top of a 4th hour shim. And you can see this one's got a shoulder on it, look. And then I believe, yeah, an E-clip's going to go on there. It was like a little sort of split ring, or rather, yeah, like a small circlip. But I'm going to replace them. They didn't, they suffered a little bit when I removed them, so I'm going to replace them with E-clips, and a kit of which I have. So I'll be using these to replace some of the damaged. Right, so I've moved you so you can see better. That's the gearbox assembled now. So this is the gear that the pinion from the motor drives, and as you can see, it drives through and gives an enormous reduction. I'm not quite sure what the reduction is, but it's pretty huge, so that the output shaft turns with plenty of torque and nice and slowly. So what I have to do now is to put a couple of E-clips, one on here which secures this cluster in place, and then one on here which secures that cluster. This one's secured in place because when we put the motor on, there's 2 little bores that engage with these 2 shafts, and there's a spring that goes on this one that just gives a bit of preload to the whole thing. So that's held in place by when the motor's pushed on, and this gear is held in place just by a small E-clip against that boss. So they're going to be 3.2mm E-clips, or 1/8 if you like, because these shafts are 1/8. So we'll get that on now, and you get to have all the fun of watching me trying to get one of these on and losing it. Not just losing the E-clip, there is the E-clip, look, but losing my temper. I'm going to try not to lose my temper. I try not to do that. It doesn't get you anywhere, does it? Right, I can't. I thought I might be able to push it on with my fingers, but I can't. So I need to have my Weetabix in the mornings. See if we can get it on with a pair of pliers. Yep, that's that one on. Nice satisfying click there for the camera. And if I can pick the other one up, get it into position, it should go on relatively easily. Hopefully you can see what I'm doing. Yes, you can. And that is, oh no, it's not. It almost, come on, don't mess me around. It's getting stuck with the grease, right. That's that one on. Okay, so gearbox, or gear cluster rather, assembled. It'll form the gearbox once we put the motor on top, and we have to feed the 3 wires from the motor, the 2 field connections in the ground, through these respective holes here. So here's the motor portion, here's the gearbox portion, and the 2 are about to be reunited, and you can see I've put the preload spring on there, look, now that we've fitted the E-clips. And what I'm going to do is to put a little bit of Loctite 574 flange sealant just around here, around the motor flange, where it goes onto the gearbox, just to give us a bit of weather seal and prevent any moisture getting in there and dissimilar corrosion. Not that it's really going to do that much, because I think the corrosion was primarily caused by condensation, but it, well, I don't know if I should be filming this really, but let's try and put these 2 together. So that cable has to go through there, and then these 2 go through these 2 respective holes here. Hopefully you can see what I'm doing. I think you can. Right, now we have to somehow get that, yeah, get those through there, get that spring in and get that piece engaged, or that shaft engaged with a little bore that's inside the motor casing, and also get the pinion engaged at the same time. Well, something's happening. Yeah, I think the motor pinion isn't quite there. Let's just separate it again. Let's just maybe turn it slightly. Try again. Yep. I think it's just going to be luck if we get that motor pinion just right. Right, I'll bring you back. You can see what the situation is. Right, I've now got 2 screws in, and you can see there, look, there's the nut, and there's the other nut, and there's the countersunk screws. You can just about see them inside there. So, they fought me every single step of the way, as you can imagine. I want to give this a try now, and if it works, I'm going to celebrate by going for some lunch. So, let's give it a go. This is another stage check. And right, so Houston, we have a problem. My expected for triumph has not yet materialized because the brake's coming off, but it's not turning. Oh no, wait a minute. I think I've wired this up wrong, haven't I? Oh no, I haven't. Right. Yeah. Might have a problem. Right, so lunchtime, I think, and then we'll have a look at it and see why it's not working. Right, I'm back from lunch and we have some small cause for celebration. So here we go. Watch it call me a liar now. Oh, look at that. She's running. The most boring will it start video ever, but for me it's the most exciting. And that's it running the opposite way. So what's so great about that? Well, it was just a lump of corroded mess, a homogeneous mass, and now it's starting to become a functioning operational mechanism again. So that's really good. And what was wrong with it? Why wasn't it running? Well, I just think that the gears couldn't have been properly enmeshed with the pinion on the motor, because when I took this off, I reinserted it and it worked. So the only thing I can think of is just incorrect mesh in the gears, or in the pinion and the gears rather. So there you go. Well, we'll continue to reassemble it and we'll get the switch plate on and see if it works properly. Right, so we haven't entirely got past all our little niggles. You just saw it running there, but that was without it being bolted together, just pushed together. When I bolted it together, it refused to run again. And what I think is, this E-clip that I fitted here in place of the little split ring that was originally there, I think that's fouling on the pinion of the motor, because if I can turn that round so you can see, the motor pinion has a little bore in it which is meant for this shaft here to see into, this shaft here to see into. So I think the E-clip here is preventing that from happening when everything's, that's just making an extra bit of thickness, and when everything's tightened up, that E-clip is pushing against the pinion of the motor and it's jamming everything up. So we'll take that E-clip off and see what happens. So I've still got the same issue even with the E-clip removed. I've tried now to assemble the unit and then slowly tighten up the bolts with the unit running, and when I nip this one, this bolt here, it stops. It's fine with this one on this in this corner nipped up, but as soon as that one's nipped up, it stops. So it's something in that corner. I'm just wondering even if it's the thickness of the paint inside there that's fouling on the gears, because there was a witness mark in there. But I'm going to take it apart now and try and fathom out what the problem is. It's clearly an issue with, you know, the clearance in there. And those 4 thou shims are tiny that are in between the gears, but we'll have a look anyway and see if we can find out what the problem is. Right, so after further inspection, and I'm trying to hold the camera still, hopefully you can see on that gear there is a grey witness mark, and that grey witness mark has come from the paint on the inside of the housing. So I believe that it is literally the thickness of the paint that has been binding up this gearbox. So I've scraped all the paint off the inside of the housing where the gear runs. So we'll assemble it now and see if that makes any difference at all. Right, so I've reassembled the motor to the gearbox, and I want to show you what the issue is and give you a feel for it. I have took the paint off internally, as I described earlier when we were looking at just now, when we were looking at that paint witness mark on the drive gear or the driven gear. So I'm going to get the motor running now and I'll show you what the problem is. Basically, if I tighten this screw a quarter of a turn, the one in this corner, it stops it. So just by doing that, I can stop it, and I can start it again. So it's got to be something to do with the clearance of the gears, I think. So I'm going to have to revisit the gearbox or the gear cluster build-up. So after the trial without the paint, I'm hoping you can see it didn't run, but there is still a witness mark there. Can you see it? That's come from the gear. Just there. So what I've done is I have made, using a file and just careful handwork, I've made a slightly smaller shim for one of the gears in the gearbox, because there was this shim here which is 0.101, and I've managed to make a shim that's a thou thinner than that just by careful work with a file, because you know it's a bit of a quick and dirty thing, because I just want to test it quickly to see if it works. So I've assembled the gearbox with that slightly smaller shim and we'll see what happens. Right, so this is almost astonishing, although I suppose it shouldn't really be. Obviously there was very, very small clearance in it, because a quarter of a turn of a 4BA screw was the difference between it running and not. So I've just spoken about this thou smaller or thou thinner shim that I've made for it using a file, with very careful handwork, and I've tightened up the 2 screws now with you know, as tight as I can get them, really, with the tools that I've got, tighter than they were before, and would you believe it, it's running. And that is just well, I suppose it shouldn't really be amazing, but it has kind of taken my breath away somewhat. Just goes to show you the tolerances that we're dealing with these devices, but kind of shocks me somewhat because I don't understand how it worked to begin with. But there you go. These things are sent to triers, I suppose. So that's the offending article sitting on that pick. That is 101 on the vernier, and the shim I made out of a piece of very small bore tubing, or 1/8 bore tubing, with a file and just very, very careful handwork, was 0.100 on the vernier. So it was literally a thou that was in it that was stopping it from working completely normally or not working at all. So I've got the micro switch housing in now, and you join me as I begin wiring up the switches. You can see there that the clockwise switch is made by the cams and the anti-clockwise switch is currently unmade. So that's in the correct position. I've marked these up, so yellow is the counter, red is clock, and black is obviously the ground, and that's in accordance with the book of words. So I will now start wiring this up. I've got the ground connection here and the output ground that goes to the plug. They both go on to that stud or bolt there, and I think the reason for that really was just I don't really know, because it's actually grounded. It's not grounded, but it's insulated, but I'll do it the way it was, and I'll bring you in when I'm starting doing the soldering. Right, so I'm making the last connection now. Just going to tin this wire. This is the counterclockwise field wire. I'll just cut a bit of that off, it's a bit long. So once we've got this one on the appropriate micro switch, we'll be in a position to make a functional test of the unit in terms of it rotating clock and counter and stopping in the right position. I'm going to shorten that a little bit more actually. Better, right. Also the wiring will get tidied up. Oh dear. Just melted the soldering iron cable, but never mind. These things happen. Right, final connection made. Soldering iron unplugged before I burn anything else, and I'll bring you back when we're testing. So there we are. The micro switch plate is wired. The wires will be tidied up a little bit before I put the top cover on. And I want you to cast your mind back to a few weeks ago, or even a month or so ago, when that was just a homogeneous mass of corrosion and just a big horrible white corroded lump. And it is now a fully functioning mechanism. And I'm going to show you how it works, and I'm really happy. So this is a quick view inside the unit, and I'll show you what goes on when it goes from clockwise position to counterclock. There you go. And now we'll do from counterclock back to clock. This is from counterclock back to clock. Thing of beauty. Well, that's the end of another one, folks, and here it is, completely reassembled. The end cap's on now. I've just put the little snap ring in the end that holds the drive shaft in. It's all functional. You might be wondering what I'm going to do with these. I'm not going to refit the breeze connector. I have a plan in mind that will replace the breeze connector with something a little bit more budget conscious. Breeze connectors are extremely rare, and therefore they are very expensive. So I've got something that's going to look the part but isn't going to break the bank. So we've gone from what was an atrophied, homogenized mass ravaged by corrosion to a functioning, useful, intricate mechanism. I'm really pleased with it. It's the first part of a big puzzle, and I think I want it to set the standard for how we proceed with the rest of the engine. So I hope you've enjoyed this video. Give me a like if you have enjoyed it. Give me a thumbs up. Remember to subscribe if you're not already subscribed. Approximately 50% of the people who watch me aren't subscribed, so please do so if you're not. It doesn't cost anything at all, and I will be beamed directly to the tiny little computer that's in your pocket. If you are already subscribed, remember to click the bell icon so that you always get updates from me when I post new videos. The next video will be another turbine related one. It's going to be about the mystery component that arrived in the box that I spoke about earlier on in this video. After that, we're going to have to move back onto the milling machine and get some work done on that. So I'll see you on the next one. Take care of yourselves, and Merry Christmas.